In 79 AD, in the ancient Roman town of Herculaneum, 20 meters of hot mud and ash buried an enormous villa once owned by the father-in-law of Julius Caesar. Inside, there was a vast library of papyrus scrolls. The scrolls were carbonized by the heat of the volcanic debris, but they were trapped underground where they remained preserved. It wasn't until the 1750s that the scrolls were discovered, but they were fragile and resistant to being opened and read. Then in 2015, researchers used X-ray tomography and computer vision to virtually unwrap the scrolls. Last year, the Vesuvius challenge was launched by Nat Friedman, Daniel Gross, and Brent Seales to crowdsource the process of reconstructing the text from the scrolls. Juli Schilliger and Youssef Nader are two members from the winning team. They joined the show to talk about the computational approaches they use to reconstruct the scroll text. This episode of Software Engineering Daily is hosted by Jordi Mon Companies. Check the show notes for more information on Jordi's work and where to find him.
Hi, Julian. Hi, Youssef. Welcome to Software Engineering Daily.
Hi, thanks for having me.
Yeah, hello.
Before we jump into the topic that brings us today, I'd like to know if you guys had any, or have still, any particular interest in ancient history or ancient texts in particular.
So I'm living in Switzerland and we also have lots of Roman artifacts and ruins here. So since I was a little child, we would sometimes go visit such ruins, and that was about the extent for some time. And after that in school, I also heard from ancient libraries and how they got lost over time because they had scrolls in them and you couldn't really conserve scrolls, especially in the Mediterranean area where scrolls just deteriorate and maybe over 100 or 200 years get lost. And yeah, that's my starting point there.
What about you, Youssef?
Yeah, for me as an Egyptian, I think you grew up learning a lot about ancient history, and
it's literally everywhere. You can't escape it, right?
Exactly, and you go like throughout, like it's so much. 7,000 years of civilization is quite covers like a big curriculum for 10 years or so. And yeah, I think the word like papyrus was the kind of thing that got me hooked because we grew up learning that it was like invented by ancient Egyptians to sort of document history and daily life and that sort of thing. So yeah, for me that was kind of the hook for the Swiss challenge, like that ticked.
And the good thing about the difference between Egypt and Switzerland is that actually things are preserved much better there because of the dryness than it does so in the rest of the Mediterranean. Okay, so what about computer science or just tinkering with software and technology and the technologies that eventually allowed you guys to win the Vesuvius Challenge Award last year? What is it that hooked you into computer science? What are you doing right now as a job or studying in computer science or tinkering with technology, both of you?
So for me, I started this journey of studying computer science out of the idea that computers are probably the most powerful tool that we have today, and I wanted to master them, or still I'm in the process. I guess no one really mastered them so far. And from that aspect, I wanted to help humanity with computers, take away some tedious tasks that no one would like to do. That also brought me to computer science and later on to robotics, because you have lots of laborious tasks in the physical world as well that need some help and that, humans wouldn't really like doing.
How old are you and what are you studying currently?
So I'm 29 right now and I'm recently graduated from ETH. I did a bachelor's in computer science and my master's was in robotics, also at ETH.
ETH is really renowned, one of the most renowned computer science and many other fields, engineering fields, universities in Switzerland and the world. What about you, Youssef?
Yeah, so for me, I did my bachelor's in communications and computer engineering. And yeah, I grew up really loving math and I wanted to pick a heavy math focused major. And I wasn't initially going to pick communications and signal processing and analysis, but software engineering just grabbed my heart. And in the end, I ended up doing lots of machine learning in my final years of bachelor's. Then I came to Germany, did my master's at the Free University here, and now I'm pursuing my PhD, focusing on AI, explainability, and self-supervised learning. I mostly work with 2D images, and the Vesuvius challenge sort of presented this more complex data format that I was just eager to play around with.
The title of this episode is probably self-explanatory. We've mentioned it already during this interview, the Vesuvius challenge. For those that don't know anything about Mount Vesuvius or Volcano Vesuvius and the challenge, does any of you want to take a stab at explaining what was the goal of the first edition of this challenge?
Yeah, sure. So maybe we can go back a little bit for a small history context. So around the 17th century, a farmer was excavating in Italy and he found something that looked like a piece of charcoal. It didn't look quite like the other rocks, and that was when the first scroll was discovered from the collection, the Herculaneum collection. From then ensued a series of attempts of trying to read these scrolls, and a lot of these attempts were quite invasive. You're trying to open
to
them,
say the least.
And you can imagine these pieces of these scrolls have been under so much pressure, so much heat, so much debris for a very long time as well. So they're very, very brittle. Touching them might make them crumble. So these attempts destroyed a lot. And over the years, some progress was made of the machine of the Piaggio, where you have you break off pieces and you stitch them on a membrane. That also was a very destructive process, but that was the best that we had. Then a couple of years, so in 2000, I think around 2010s, and Professor Brent Seales at the University of Kentucky developed this method of virtual unwrapping. And so he did a lot of work on how to sort of virtually open these scrolls so that we can manipulate them, look at them on our computers rather than doing this physically. And this works well for scrolls that are specially made from where the writing is, the ink contains some metal, because when you scan them in a CT scan, for example, and you open them, there's quite the contrast that you can see, and then you find the ink, you can read them. The challenging thing about this collection was the ink was carbon based. So you look at it in a CT scan, which is a more sort of sophisticated version of the X-ray you'd get at your doctor's. You'd see that it's blank. We know the ink is there. It should be preserved. And there are pieces that fell off where we see the ink. But when you look at it in a CT scan, it's empty. It's not completely empty. And some contestants in the challenge have proved this, but you don't see anything. And yeah, this is sort of where the beginning of the Vesuvius challenge.
Yes. I need to stop you there because you're getting into the nitty-gritty of it, which we'll cover in a minute. It's really super interesting. So yeah, place yourselves in ancient Rome, I think 1st century after Christ, 79 AD. And that's when Herculaneum, small village close to Pompeii, the famous Pompeii, got covered with ashes mostly and all sorts of debris from the eruption of Mount Vesuvius, a volcano nearby. And that covered completely not only the whole town, but Lucius Calpurnius Piso's house, which was a really powerful guy. In fact, the father-in-law of Julius Caesar and the owner of a ton of papyri. This guy must have loved to read, and he had a ton of money to bring in people that wrote, copied, translated text for him in his really famous library, which is the one that Youssef was describing, was discovered in the 17th century. And then we went through all that iteration of processes of trying to discover what's written in those. The first approaches were quite dramatic. They even sliced and cut the scrolls. But anyway, we've got better to the point that now we're able to read, hopefully, what's inside. So, Julian, how did you come across the Vesuvius challenge? How did you find about it? And what was the task that anyone joining the challenge had to attempt to solve?
Okay, so this challenge was created by Brent Seales and Nat Friedman. They were the initiator, and the task was to open a still rolled up scroll and read it. For the grand prize, you had to read 4 passages of 140 characters each, where 85% of the characters had to be readable. And that was the starting point. You had the CT scan of the scroll, and there you go. You can download it from the internet and start. And when I came to it, that's all there was. There was also a competition on Kaggle to read some of these CT scans, you have to imagine some of the pieces of this scroll flake off, fall off, and you can read some characters on those small pieces. And those were used as ground truth data in the beginning to develop machine learning models on it. So that one was running, and well, we hadn't a way to access the scroll. We had to unroll it first. And after I developed some initial machine learning model that's performed quite well on the fragments to my knowledge, I started extracting some of the sheets, and there was a tool that was developed earlier over the past 10 years called Volume Cartographer that was developed by Brent Seales teams. And I tried using it, and it sadly didn't work. Like, it was way too slow, too clunky, had lots of issues, errors, broke and crashed. It was like, you couldn't even extract one character.
By the way, when you say unfold the scroll, you mean digitally, right?
Yes.
Okay.
So, and even like unfolding wouldn't probably be the proper term. It's more of a unrolling since it's not folded.
So volume cartographer did not work. So that got you, I guess, thinking of other ways to do it, right?
Yeah, so I thought the framework was quite nice, and the ideas on how to structure this task was also quite in the right direction, but just not there yet. So I developed some segmentation algorithms. Maybe we have to say what segmentation means in this regard, because it's something different than in computer vision generally. So segmentation is actually the process of extracting this sheet, this surface of the papyrus. And you would do it in Volume Cartographer by drawing a line, a curve. If you imagine the scroll, it looks a little bit like a tree stump, just like a spiral if you have it rolled up, and you're going to trace that spiral. That's the first step. And then you give this spiral to the computer, and it will compute it through the volume. So you have like one slice through this scroll, and then the spiral gets computed upwards through the volume to extract the surface actually. So I developed some algorithms that actually compute this scroll upwards through the CT scan and stay on the surface. You have to imagine this surface is really, really twisted and broken, has tears in it, fuses, sheets are fusing because this volcano was really destructive to those scrolls. Yeah, that's how I started. There were people using these tools. So it's a manual approach. You have to do work to actually extract those sheets. And so I started developing Volume Cartographer further and got inputs from the people that were using it.
Okay. What about you, Youssef? How did you come across this, and what was your first approach to it? Did you also leverage like previous work, or did you like start from scratch yourself? What was your first ideas to tackle this and become a champion?
Yeah, so I first heard about the challenge through Kaggle. So I usually keep an eye for interesting Kaggle challenges, and I saw the ink detection competition which was running there. My first idea was to sort of treat the ink detection problem as a regression problem, try to predict like the average intensity of ink or no ink rather than like the binary, in order to sort of tackle a few issues with like different orientations of the image, different noise levels. The CT scans like were quite different from one another. And it worked. I'm actually not sure like how well it works or it fares like today, but it was like sort of a stray idea that I looked into. At the time of the Kaggle challenge, I was also writing my master thesis, so I was pretty busy.
Yeah, me too.
Yeah, so I think fun fact, like we both finished our master theses in the same month. Yeah, so that was like my start with the Vesuvius challenge, but it sort of was quiet for a couple of months after. And then I just kept in touch, and I saw that even the winners of the Kaggle competition couldn't really see ink on the scroll, which made me very intrigued. And then I was starting to learn about self-supervised learning and how you can like learn some stuff from unlabeled data and then transfer that knowledge to labeled data. And it's usually very powerful when you have like a lot of unlabeled data and just a small amount of labeled data. And I played around with it. It sort of pushed me in the right direction. It wasn't like complete success, but it wasn't a complete failure either. And that's when I first like found the first couple of letters and made this like sort of iterative process where you can like your model becomes a teacher to teach like new models what ink looks like, and these new models themselves become a teacher once they learn what ink is. And this like process repeats until you get like really good models that really understand what the ink is.
2 questions before we move on to something deeper dive actually into the topic. What were the first 2 letters?
It was a pi and an O. I mean, yeah. I'm not really like knowledgeable in Greek, so I call them
no
like...
worries. No worries at all. What was it about the ink that you glanced through at the beginning? There was something about the chemistry of the ink that made it particularly challenging?
Yeah, I think it was a lot of factors. Like for the Vesuvius challenge, there was a lot of factors. The technical part was definitely very interesting because you get access to this like 2,000-year-old data that you can download on your computer and play around with. Essentially, it was like 3D data or 3D images. Like once you zoom in on the sheet, you can also see the thickness, right? So it's essentially this. It sounds like it should be straightforward, and we sort of had like a proof of concept that how it should work, but it was sort of obscure. Like for some reason, it wasn't working. And this jump from we had some very good models for the fragments, and this was even tested before the challenge from like prior work from Stephen Parsons' PhD thesis. So we sort of knew what the flow should be, and this was actually also the eventual flow. But getting it to work on the scroll, the unopened scroll, was sort of a technical mystery, which is for me was like the hook.
Before we actually double click a bit more into the solutions that you guys talk to me, any of you, about the competing dynamics, like when the behavioral aspects of either deciding to collaborate with this guy, Youssef, I'm talking about Julian now, or Youssef. How do these mechanics, how do these behavioral patterns work? And how do you decide upon collaborating or just literally competing on your own? Be completely honest.
Yeah, I mean, I think it's game theory, right? Yeah. Probably. But I think the design of the challenge was just like really great. You had this big prize money for the grand prize that drew people in, but then actually there were also smaller prizes. And if I say smaller prizes, I still mean like thousands of dollars for prizes that kind of hooked the community, and they were periodically given out, and you could share your information. You had to make them open source to win those prizes. And so some collaboration was actually fostered throughout the year, throughout the challenge, and people that shared often and a lot were recognized and had like a cool, good standing in the community. We had a Discord server where most of the action is, or we still have that server. So come join us on Discord. And there we just exchange ideas and improve stuff, share things. Yeah, that's how we got to know each other. I mean, Youssef, me, Luke, we all were active in the community. We all won prizes, those smaller prizes. And so, yeah, every one of us had like something to bring to the table, and we've shown that throughout the year.
So you took volume cartographer to another level, right? Tell us about what you actually assembled, how you called it, why you called it in such a way, and what did it actually do, and how did you get the prize you won through this technology?
So I identified quite early on that the problem with volume cartographer, the main one was that the segmentation algorithm was too slow and not accurate enough. If you could increase the accuracy, you wouldn't have to do so much human work, and you could like do more with your time. I'm quite lazy.
What made it slow?
Let's start with like the slowness, the algorithmic choice. Just the algorithm that was used was really bad. It was not implemented correctly, and like single-threaded implementations, those data that it used, the data was really big. So there's also a need to handle the data appropriately. So you have to load it in a certain way to be fast, prefetching data, for example. And yeah, for like the slowness and the accuracy, just using a different segmentation algorithm to propagate the line throughout the volume was the key. And there I took inspiration just from, if you have a video, there's this problem of tracking pixels or objects, and that's called optical flow. And if you look at this 3D data, you could also just have it as a video, 2D images, and then going through the volume as the time dimension of the video would be the third dimension. So you kind of have this video where you could also apply optical flow to it. And that's how I could track my curvature of those sheets, track points from one frame to the next, and have this curve follow the sheet through optical flow. And that's how I decided to test it out. I called it optical flow segmentation because of that. And the main workhorse underneath it is optical flow. From then on, I had lots of iteration and testing with people that actually used this segmentation tool. Those gave me nice inputs how to smoothen those lines. And so you have to see the sheets are bright, showing up bright in the CT scans, and the air around it is black. So if you move out of the sheet with your curve, you move into the black area. And so the computer could itself tell that if you just set a threshold, maybe move the point, the line back into the sheet, or at least try to do it. And so those were things that I used to get more speed and more accuracy.
Is that what granted you the award? Is that contribution?
Yeah, so multiple iterations of this algorithm. So you have to see if you just calculate how powerful the tool was, how much sheets you could extract, like the area. There was like a 10,000-fold improvement of this segmentation tool. So yeah, maybe every time I had like a 10 to 100-fold improvement, and that 3 times made like a 10,000-fold improvement. And for each 100-fold improvement or so, I won a prize.
So what is Taubato and a Calapto then?
So yeah, this last volume cartographer program uses human labor, and it's quite expensive. Actually, for the grand prize banner, that's 2,000 letters that we read. It cost around about $200,000 in human labor. My goal was to extract more sheet area quicker and fully automatic, to just have an economic way to read the scrolls. That's how I went back to the drawing board and applied all the lessons that I learned from developing further on volume cartographer. So it's a pipeline. It splits this problem in multiple smaller sub-problems, starting with extracting surface points on these sheets, just like a point cloud. You have to imagine having a point cloud, lots of points on the surface of the sheets only. And if you look at it with your own eyes, you can see like those rings in 3D, those spirals and the sheets. But yeah, only point clouds. So 3D point data, no connectivity information there. So next step would be getting back this connectivity, how the points connect. Getting back this connectivity means, well, now you have connected point clouds. Now you have to kind of mesh it, because sometimes the points aren't quite accurate. And yeah, so you need to mesh it. After that, if you have it meshed, then rendering it, having your virtually unfolded surface in front of you where you could apply ink detection on.
What about you, Youssef? What technology got you the prize? How did you call it? How did you build it? What did it deliver?
So I mainly focused on the ink detection problem. Once you have like the flow of the segmentation, you have like the 3D image where you need to detect the ink. And from the Kaggle challenge, there were like some established findings of bigger models are better, predicting on like a wide context. So these images are usually huge, like thousands or hundreds of thousands of pixels by hundreds of thousands of pixels. Of course, there's no way of putting all of this into the model in one go. And the idea that was running was that you run a sliding window over like the different, and you do this on sort of a pixel level. Is there ink or no ink? And you do this like as a segmentation problem or an instant segmentation, because the terms will get confusing. And then once you have like the ink, the interpretation or the reading, like the letters, is left for us humans. When you zoom out, you see like what the writing is. And for the Kaggle challenge, most of the window sizes were like really large. So my journey started from like using self-supervised learning to pre-train the network on the scroll, the unopened scroll, and then fine-tuning with whatever fragment data that we have. This sort of helped the model the very first like 3-4 letters. And from there, I remembered this like idea that I saw before on Kaggle, where you can take like the predictions from the model. If you don't have like certain labels, you can take the predictions from one model, turn them into labels, and train like a completely new model. So nothing shared between the two models. And the new model learns like the signal from also now like the first model. Lots of work went into preventing overfitting, which is you'll run into the problem where your model just memorizes what you want. And this is like a very big issue because you pretty much showing the model what it needs to do. So it might just converge to being the previous model. If your labels are wrong, then there's really nothing to learn. And there's no actual signal behind your labels. So it would just memorize like the patterns
It's a
of the CT scan.
monkey repeating, gesturing
Exactly.
back.
Yeah.
It's
Like
like
monkey
mirror,
see,
right?
monkey do. And this is what you end up with. So a lot of work went into like kind of how do you prevent overfitting and how do you allow the model to sort of talk back, to sort of like reject your labels if they're wrong and be able to like still, if you say that this area has no ink and you train the model that it has no ink, but the model sort of sees that this is the signal you're looking for, it should have like some leeway, some way of like not being too heavily penalized for my mistakes. So a lot of like regularization and testing, and in the end, this pipeline of like iterative pseudo labeling did like quite an incredible job in finding letters. So I went from like 5 letters to many letters read very quickly. And then when the ink banner, this was like the announcement that we have letters from the scroll, the ink banner was sort of kind of getting this approach like really, really right. For the next like 2 months for the grand prize, I did a lot of these iterations and sort of testing, okay, like is it better to overestimate the labels or to underestimate? Is it better to be more conservative or less conservative? And what sort of labeling techniques? In the end, I found that the best way of labeling and sort of comparing the models was to do this in Photoshop, because you can just flip back and forth between the predictions and see like if the predictions are improving. And it was sort of, how do you scale the data? I did a lot of iterations and data was coming. And another question was, how do you to use this data efficiently? And in the beginning, like from the beginning of the competition, I had like this idea that there's usually a lot of redundancy. You're scanning at a very, very high resolution that from one sort of cross section to the next, there's not that much difference. You're that zoomed in, there is some redundancy. And I thought, okay, it may make sense to just look at the spatial image and then try to find a relationship between the two, between like the depth. So find like some information of the spatial, like the XY, and then try to find some relationship between the Z separately, like say, okay, I see this pattern here, I also see this pattern repeating throughout the depth, so maybe this is a letter. I tried to do this with like convolutional and LSTM networks and some other attempts. It worked, but it wasn't like really what I'm looking for. Then I came across this paper from Meta Transformer, which sort of looked at this problem of, you want to do a transformer, which, it's sort of one of like the key aspects of transformers, where we see them everywhere today, from natural language processing to images. They scale very, very well. So they looked at the problem of, if you have like some 3-dimensional image data, what's the best way of doing the attention mechanism in this 3-dimensional space? And they looked at many different variations of the attention mechanism in 3D. Some were even like some sort of a hacky heuristic approach. And their final like finding was that they do this kind of idea of, you learn some stuff from the spatial dimension, and then you only look at yourself. Like the message passing only happens through the depth. You look at yourself and then you exchange information. Okay, I see this pattern here, I also see this pattern here, so maybe this is ink. And this was sort of a culmination of this idea. It took some work getting it work on the Vesuvius challenge. For some reason, it was very, very, very sensitive to any like parameter change or any change in the setup. In the end, I got it working around like end of November, right before I teamed up with Luke. And yeah, I was really surprised by the findings, because the predictions looked really good. The model was able to find ink that it wasn't able to find before. I sort of like knew, yeah, this is the model that's going to make the final cut. And from there, it was sort of getting both approaches, like juicing out like the last 2 letters, because the requirement or the criteria for winning the grand prize was 4 paragraphs of text, 85% readability. And that 85% readability actually proved to be like a very big hurdle. And in the end, we were the only team to cross that threshold. And it took a lot of these like iterative steps to sort of refine the model predictions and to find like those final 2-3 letters in every paragraph. And this is my story with the challenge.
Nice. One day we'll look back 10 years from now, 20 years from now on the Transformers paper, and we will realize how much value that paper has unlocked, because it's crazy how much, again, value in many senses that paper has actually just delivered to everyone. So Luke was unable to join, Luke Farritor. Could you give us a sense, by either Youssef or Julian, about what was his contributions?
Yeah, sure. So Luke, at the time I was working on the first letters, was also working on the first letters with a slightly different approach. So I think around June, July, a contestant named Casey Hanmer, who was awarded the first ink prize, he found like some patterns by just looking at the scrolls. I said, yeah, well, my eyes are neural network as well, so I'll just use my eyes and try to find patterns that make sense to be ink. And he actually found a pattern that resounds with ink.
Can I stop you for a second?
Yeah.
Did he just say my eyes are neural networks?
Yeah, I think he said that somewhere in his blog post.
That's great.
Somewhere, like I do remember either reading it or hearing it. But yeah, correct me, Julian, if I'm wrong.
I think he said that. Yeah, he's a cool guy too.
Yeah.
So he found these patterns, and these patterns actually do make up the ink, or at least some portion of the ink. And he was successful in finding some letters, and Luke started working by looking at these patterns and trying to train a model. So supervised learning, this is the patterns that you have, try to find the ink, which is very similar from my approach, except that you're relying on your eyes to create like the label data. And he was the first to win. So he found the 10 letters and he won like the first place in the first 10 letters prize. And then he was pursuing a mixture of automatic and manual segmentation. There was one very big question for us, which was where are the letters that we cannot see? So there, if you look at the predictions that we have, there's a bunch of letters missing. There are some areas that the model predictions just go dark. And it actually was a lot of effort trying to figure out what was going on there. Is this a problem in the segmentation itself, that it missed like the sheet, or so there's nothing for the model to predict? Or is the data there, but the model is unable to see it? So I tried to focus on the latter, like, okay, what if it's a model problem? And Luke spent a lot of time like investigating this as a segmentation problem. He even like resegmented some of the portions by hand, some of the segments that we had, resegmenting them, trying to find what the problem was. Or if there's like some damage in the scroll, like the letter is not there to begin with, it's not impossible to find. So he focused on the manual segmentation, but also explored like automatic segmentation.
So what does then this group present? What was the final submission, the contents of it in many levels? Like what did you hand over and what did it say? And by this group, I mean the two people that are joining me today, Youssef Nader and Juli Schilliger, but also Luke Farritor, which we mentioned. What is it that you handed over and what gave you the price?
We handed over the code actually to produce the images that make up the text. So what Youssef told us about before, those models predicting the ink and having the grand prize banner actually predicted, I guess. We had to choose 4 columns of text that we thought hit the threshold.
Okay.
So that was one part of the submission. Also multiple different ink predictions there. We had 2 main models, the Timesformer, another one as well. And so that was the big part of it. And then as a surplus, because we weren't sure at that time how much letters we would see if we hit the threshold or not, we also submitted this Taumato Anacalyptor initial development tool. So it wasn't finished in the sense of that you could read the complete scrolls with it, but you could read some parts of it, like unroll it, not read, of course. So this automatic segmentation approach was also part of it.
I'm fascinated because I don't know if I mentioned at the beginning, but I'm an ancient history major. I'm fascinated by all of this. If I had to pick sides between Rome and its arch enemy, well, the Punics, a strand, I guess, of Phoenicians, I side with the Phoenicians. I like them better. So I'm actually very pleasantly surprised that the first word to be not discovered, but read, I guess, was purple, right? Which is probably making reference to the purple dye that came famously from Tyre. Who knows? I mean, this is just absolutely fascinating. Again, 1,800 scrolls, if I'm not wrong, still preserved, not damaged. That techniques like these and open source technology like the ones that you guys have developed and the next, because the challenge continues, and we'll talk about that in a minute, is going to unveil so much information. In fact, before we move on to this challenge, to the next edition, this year's edition, 2024, of the Vesuvius Challenge, which is again ongoing, and you guys are involved at a different level. I just heard, I don't know if you guys are aware, that the University of Pisa has also conducted a few types of research on papyri from, I believe, Herculaneum. Were you guys aware of it?
Yeah, so we have two different data sets, so to speak, the unrolled papyri and then the still rolled up papyri, and I believe they worked on the unrolled ones. There's also still a lot of research to be done there to have them read properly.
So are you aware if they used your software?
Oh, no. So they used like spectral imaging, so no CT scanning technology that was used there.
I believe they unveiled a text about Plato, and Plato being returning from Syracuse, that terrible journey that the Athenians, battle that they engaged in which thousands of Athenians lost their lives. And I think they unveiled a piece of the life of Plato that was quite obscure. But anyway, regardless, still a lot of information, still in the early stages of both techniques, both approaches, both data sources. And I'm as a consumer of this, I'm extremely happy. So tell us, what is your involvement in the Vesuvius Challenge 2024 edition? And I guess if you can give us a hint of where things are heading, like, are they taking your contributions, making them better, extending them, or have the people involved in this year's edition decided to take a different approach, start from scratch, from a different angle? What's going on this year?
So the best thing about this challenge is you just, if you have an idea, you can just do it. No one's going to tell you, no, you cannot do it. So all the information from last year is open source, all our tools. So some people's try improving those tools, and already some of the work improved some of those aspects, like better imaging, labeling techniques, better labelings. And yeah, also new stuff like full 3D ink detection just dropped a month ago. So
wow.
Instead of unrolling the scroll first, just first predict the ink in it and then unroll it. So yeah, lots of different approaches. For me, I changed sides. So I'm not a contestant anymore. I'm now part of the organizer team. And there my job is to develop further my unrolling technology to get to a state where we can unroll all the scrolls that are in existence and have them read efficiently, economically.
What about you, Youssef?
Yeah, so for me, I'm also sort of not competing, but I'm still very interested in the challenge and sort of helping out in any way I can. So I had like a lot of ideas throughout like the past year and early this year on how to like read the rest of the scrolls, or more generally, like how to not unroll like all of scrolls like Julian, but how to read all other scrolls in existence once they're unrolled. And I got reached out by this other project here in Berlin, which is working on Egyptian papyrus. And I started like trying out my model, and I was surprised to find that my model actually kind of works. It's not like great, but it's still, they're seeing something. And like from the very beginning of the challenge, I was fascinated by the idea of having a single approach to ink detection that can read every other scroll in existence. And yeah, I'm still fascinated by that idea. I'm still trying to kind of bring it to life. But yeah, there are also other projects going on. So
amazing. So I mentioned a while back that I think humanity will be quite grateful with the authors of the Transformers paper, mostly from Google, I believe, those researchers. I could be wrong, because the implications of down the line of that paper are already revolutionary. And I think, again, it's going to bring so much good things for technology, humanity in general. I don't think your guys' impact is as big because I'm not sure. Maybe I'm missing uses of your technology, of the technology that you've contributed to the world, because after all, it's open source, that may be so useful. But to be honest, unlocking the amount of information that is going to be unlocked from the papyri villa in Herculaneum first, or just that, but other papyri, like Youssef was mentioning, there's plenty, it's going to make us ancient history lovers, and in general, those seeking to understand humanity and the history of humanity. So happy that, guys, I'm so in awe with the work you've done. I'm really grateful that you won this prize, that you were motivated to compete, collaborate, and win it eventually. I say this, I extend this also to the runners-up. There's plenty. If anyone wants to know about the Vesuvius Challenge, you can just go to scrollprize.org, scrollprize.org, and you'll find all the information about these three guys, the winners, but also the runners-up and this year's edition. But yeah, I'm just incredibly thankful for your work and your open source contributions. And yeah, I'll only look forward to the next year's edition, or the winners, and see what text they have interpreted or at least provided enough information to read, hopefully. And I'm happy that you guys are really involved. I really wish that this has a positive effect in your careers as PhD, or if you go to the private sector. But yeah, that would be my closing comments. Do you have anything else to say about the techniques you've contributed or the Vesuvius Challenge in general?
It's just a really cool project to be part of. Lots of nice people and interesting and intelligent people are part of this challenge, and just interacting with those is a joy every day. I'm really glad that I started doing it. For the future approaches and applications, I guess there might be something. I mean, this CT scanning technology, It comes from medicine. So maybe some of those tools, the ink detection and the segmentation, could be used to segment some part of the human body that doesn't really show up rightly or with a big contrast in CT scans, and could help with medicine in general. Or yeah, who knows? Maybe it's useful for something, maybe it isn't, but it for sure is a nice thing to do.
Well, Taumato Anaclypto is miracle uncoverer, so who knows what miracles it will uncover.
Exactly.
By the way, so anyone that wants to reach out to you guys to fund the repos and collaborate, any URLs, any Twitter handles, anything that you would provide anyone that wants to collaborate?
So GitHub is a nice place. My GitHub handle is Schilliger95, and otherwise reach out on Discord, join the Discord community here.
The Discord is, by the way, linked in the scrollprize.org website that I mentioned. What about you, Youssef?
Yeah, my also GitHub, so you'll find all my projects, the pre-training, the first letters, and the grand prize. My handle is Nader, so YOU Nader. And if you head to scrollprize.org, you'll find like links to our repos. You'll find like the solutions of the runner-ups. You'll find like so much information from also previous tools and prizes. So yeah, make sure to check it out.
Thank you so much, guys. This is incredible. Everyone, I'm so glad you did this. Thank you so much. Take care.
Thanks for having us. Bye.